All right, guys, welcome back. Today we're going to look at our sixth episode, which is about more derivative applications. And our focus today is what do the derivative and the second derivative tell us about a function? That's our main focus thing. So we're actually going to look at this question. I want to start, really stressing the importance of this concept. This is not something what I'm about to write is not something you should memorize. It's something you should just fully understand forwards and backwards. So let's start with f prime. If f prime is positive, what does this tell us about f? This tells us that f is increasing. Now, why does that make sense? If f prime, the derivative, is slope, and slope is positive, then yes, the function is increasing. So if f prime is less than 0, we would say that f is decreasing. So now what about when it changes? So when f prime is 0 or undefined, we call this a critical point. We can also refer to those points where f prime is 0. Those are going to be the horizontal tangents for f, where the slope is 0. Undefined won't always be a vertical tangent. It could be a sharp point on the graph. So when f prime changes from positive to negative, it changes from increasing to decreasing. This will be a local or relative max for the function f. And all of this is about f. If f prime changes from negative to positive, we would say that f has a local min at that point. So this is kind of our first derivative analysis. All the things you should kind of understand about what the first derivative tells you about your function f. Okay, so what about the second derivative? And I'm going to do an extra connection here. So let's start with positive. If f double prime is positive, the first thing this tells you is that f is concave up. And it also tells you that f prime would have a positive slope. If the second derivative is the derivative of f prime and it's positive, then f prime is increasing. If the second derivative is negative, this tells us that f is concave down and f prime is decreasing. If f double prime equals 0 / undefined and changes sign, we call this a point of inflection for f. But don't forget, these are also f prime's local extrema. So how could you be tested on this? That's probably your big question, right? Now that we have the concepts. Well, two different ways, or really three different ways this shows up. We have algebraically, you're working with the function we give you. Graphically, mostly with the f prime graph, but you should also know how to interpret a double prime graph and an f graph. And then you also might have a table with values for the first derivative, the second derivative, or the function. All of these are possibilities. Today I'm just going to do a quick problem involving kind of the algebraic analysis and then the f prime graph. So let's say our function f of x is equal to 4x cubed minus x to the fourth. And we're going to go on the interval, let's see. Why don't we do this from -2 to 4. All right, so we're going to begin with the derivative. F prime is equal to 12x squared minus 4x cubed. We're going to set it equal to 0 to find our critical points. I'm going to factor out 4x squared, leaving me with 3 minus x. So I have critical points at 0 and 3. Then I can make my number line 0, 3. Pick a point. So if we go with -1 over here, and I plug this into my derivative, this would be a positive times a positive. So it's positive. I pick 1 right here. Positive times a positive, that stays positive. Then if I pick a number over here, 4, let's say, positive times a negative is negative. And then we can interpret. We can say that F is increasing on, well, since we have an interval, -2 to 0, union 0 to 3. I could also talk about decreasing. We could say that F has a local max at x equals 3, where the derivative changes from positive to negative. And no local mins for this problem, but that's about it for this one. Like I said, I could do it decreasing, but I'm going to skip over that one. We can also determine absolute extrema. Remember, absolute max and min are the absolute highest and lowest points on a graph, or over an interval. And the extreme value theorem tells me that every continuous function on a closed interval has to have an absolute max and an absolute min. And remember, the way that we do this is by running the candidate test. Candidates for absolute max and min are endpoints and critical points. So my endpoints are -2 and 4. And my critical points are 0 and 3. So these are the points that I will use to test. So if we plug into the original equation, starting with f of -2, so we have to go all the way back up here. Let's see what we'll get. That's going to be -32 minus 16 is going to be a -48. F of 0 is 0. F of 3, it's going to be 27 times 4, it's 108. Minus 81, that's 27. And then f of 4 is also 0 when I plug that one in. So we can clearly see that this is my absolute min, and this is my absolute max. And you probably could have determined that 3 was going to be the absolute max from our sign change chart here, because we were strictly increasing until 3 and then decreasing after 3. Okay, moving on to the second derivative now, and what that will tell us. So if we take the derivative of the derivative, and we go back up, it's going to be 24x minus 12x squared. Set that equal to 0. 12x is 2 minus x. So we get 2 potential inflection points at 0 and 0. We want to confirm. Pick a number over here. Let's say -1. That's a negative times a positive, so it's negative. Pick 1, positive times a positive, that's positive. Then pick 3, positive times a negative, it's negative. So we can see from this, we're concave down here, concave up here, concave down here, and both of these points are, in fact, inflection points in this function. Okay, so now let's look at just a really quick f prime graph example. I don't want to make this video run on too long. So what do you do if you have to look at the graph of f prime? I'm just going to do a quick sketch right here. All right, so let's say that this graph represents f prime, the derivative of some function. And we can say pretty much everything that we just said in the last problem. If I'm asked, where is f increasing? Well, I would just look at where it's above. So we would say in this case from -2 to 0, and then union 1, 2, 3, 4 to infinity, right? Decreasing would be everywhere that we're below. I might say where f has a local min. This would be where the derivative changes from negative to positive. That happens twice. It happens at -2 and again at 4. And be prepared to justify that in words. I might ask you, where is f concave up? And remember, the concavity, second derivative, is the slope of this graph. So a positive slope, that would be from -infinity till -1. And again, from 2 to infinity, right? And points of inflection would occur here at -1, and here, 2 where the concavity changes. We can also figure out values for f using integration, but we'll get to that in a later lesson. All right, guys, thank you for watching today, and we'll be back with some more derivative apps in the next lesson. Good luck with your studying. I'll see you guys next time.